This PowerPoint presentation is on solids loading rate math. As always, I claim no ownership to any of the questions or material presented in this video, as everything is sourced off the open internet. In the following slides, I have, to the best of my knowledge, presented the proper formulas and the correct answers to the questions. This is just a study guide for wastewater treatment math. If it helps you out, that's great. So the formula for the solids loading rate, pounds per day per foot squared, is equal to the solids applied, pounds per day, divided by the surface area, square feet. As always, I'm working off the state of Florida formula sheet that they give you when you take an exam. If the state that you're in gives you a formula sheet when you test, I suggest that you familiarize yourself with it. Given the following parameters, calculate the solids loading rate on a secondary clarifier. Clarifier diameter is 90.3 feet. The activated sludge flow is 2.88 million gallons a day, and the mixed liquor suspended solids is 3,850 milligrams. So we have our solids loading rate formula. Pounds per day per foot squared is equal to the solids applied, pounds per day, divided by the surface area, square feet. So to solve for the solids applied part of this equation, we're going to be using a pounds formula. So capacity flow, million gallons, times concentration, milligrams per liter, times 8.34 pounds per gallon. If you have not figured out with treatment math, the pounds formula and the Davidson pie chart are very important when it comes to solving math problems in water treatment. So get very good at pounds formulas and the Davidson pie chart. And of course, to find the surface area, it's a clarifier, so its area is equal to 0.785 times diameter squared, because we were given the diameter. So let's go ahead and plug in our numbers for our pounds formula. So your flow of 2.88 million gallons times the MLSS concentration of 3,850 milligrams per liter times 8.34 pounds per gallon. That's going to give us 92,473.9 pounds a day. And then to solve for the area on the clarifier, it is 0.785 times the diameter squared, so 90.3 squared. That gives you an answer of 6,400.97 square feet. So we plug these numbers into our solids loading rate formula, so 92,473.9 pounds per day divided by 6,400.97 square feet. And your answer is 14.45 pounds per day per square foot. A secondary clarifier has a radius of 42.5 feet. If the MLSS is 3,125 milligrams per liter, the secondary effluent flow is 2.3 million gallons a day, and the return of activated sludge is 0.48 million gallons a day, what is the solids loading rate? I always like to pull my known and my unknowns out of word problems. So what we know is the clarifier radius of 42.5 feet, the MLSS of 3,125 milligrams per liter, a secondary effluent flow of 2.3 million gallons a day, a return rate of 0.48 million gallons a day, and what we're looking for is the solids loading rate. The solids loading rate formula, again, is pounds per day per foot squared is equal to the solids applied, pounds per day, divided by the surface area in square feet. So first I'm going to solve for the solids applied pounds per day by using a pounds formula, which is the million gallons times concentration milligrams per liter times 8.34 pounds per gallon. Now if you notice in this one, this question, we have 2.3 million gallons per day and a return of activated sludge of 0.48 million gallons a day. So we're going to have to add those together times the MLSS of 3,125 milligrams per liter times 8.34 pounds per gallon. And that gives you 72,453.8 pounds per day. Next, we're going to solve for the surface area of the clarifier. This time they gave us radius, so it is pi times radius squared. So 3.14 times 42.5 squared. That's going to give you a surface area of 5,671.6 square feet. Plug that into your formula, you get 72,453.8 pounds per day divided by 5,671.6 square feet. And your answer is 12.77 pounds per day per square foot. Given the following parameters, calculate the solids loading rate on a secondary clarifier. The clarifier has a diameter of 80.6 feet, an activated sludge flow of 2.36 million gallons a day, and mixed liquor suspended solids of 3,560 milligrams per liter. We are still using the solids loading rate formula. This time around I'm going to rewrite it and make it easier on myself to do the math. So the solids loading rate pounds per day per foot squared is equal to the million gallons flow times the concentration milligrams per liter times 8.34 pounds per gallon, and they gave us the diameter, so it'll be divided by 0.785 times the diameter squared. So you plug in your 2.36 million gallons a day times 3,560 milligrams per liter times 8.34 pounds per gallon, and we're going to divide that by 0.785 times 80.6 squared. So you end up with 70,069.3 pounds per day divided by 5,099.6 square feet. And your answer is 13.74 pounds per day per square foot. Calculate the solids loading rate on a secondary clarifier with a diameter of 68.5 feet, a flow rate of 1,350,000 gallons per day, and a mixed liquor suspended solids of 3,425 milligrams per liter. I like to pull my known and my unknowns out. So what I know is the diameter of the circle is 68.5 feet. The flow is 1,350,000 gallons per day. The MLSS is 3,425 milligrams per liter, and we are looking for the solids loading rate. Solids loading rate formula, solids applied, pounds per day divided by surface area square foot. And I'm going to use my rewritten / expanded formula. So solids loading rate is equal to the million gallons times the concentration in milligrams per liter times 8.34 pounds per gallon divided by 0.785 times diameter squared, because they gave us the diameter of the circle. One of the things we have to do first is it's million gallons and it gave us gallons per day. So 1,350,000 gallons divided by a million gives you 1.35 million gallons a day. Now that we're in our proper units of measurement, we're going to plug everything into our formula. So you have your 1.35 million gallons a day times your 3,425 milligrams per liter times 8.34 pounds per gallon. And we're going to divide that by 0.785 times 68.5 squared. So we're going to do the math to get the top and bottom. So you had 38,562 pounds per day divided by 3,683.4 square feet. And the answer is 10.47 pounds per day per square foot. What is the solids loading rate for a secondary clarifier given the following information? The radius of the clarifier is 70.5 feet. The primary effluent flow is 4,225,000 gallons per day. The return sludge flow is 1,025,000 gallons per day. And the mixed liquor suspended solids is 2,080 milligrams per liter. So the solids loading rate formula, solids applied pounds per day divided by surface area square feet. And I like to expand my formula out, so solids loading rate is equal to the million gallons times the concentration milligrams per liter times 8.34 pounds per gallon. This time they gave us a radius of a clarifier, and the area of a radius is pi times radius squared. So the first step is going to be to add the primary effluent flow to the return sludge flow and then divide it by a million to get it in million gallons a day. So 4,225,000 gallons per day plus 1,025,000 gallons per day divided by a million. That gives you 5.25 million gallons a day. So now we can plug everything into our formula. So 5.25 million gallons times 2,080 milligrams per liter times 8.34 pounds per gallon divided by 3.14 times 70.5 squared. So your top number was 91,072.8 pounds per day, and your bottom number was 15,606.6 square feet. So you're going to divide the 9172.8 by the 15,606.6, and your answer is 5.84 pounds per day per square foot. So that was a couple of questions on solids loading rate. Hopefully this helped you study and you learned something. Thanks.